Hello everyone, my name is Ananya Manoharan. Today, me and my teammates Dhruva and Ankith from 5th semester A section of Machine Learning Department at BMS College of Engineering. We will be discussing today the computational method of nature-inspired algorithm, that is Firefly optimization. We would like to thank our faculty in charge Varsha ma'am for her guidance on this topic. What is Firefly algorithm? The Firefly algorithm is a meta-heuristic optimization developed by Xinjiang in 2008. Its core concept is biological inspiration based on bioluminescence communication patterns where the firefly uses the light signals to attract the mates and coordinate behavior. In this algorithm, each firefly represents a potential solution to the optimization problem. A firefly brightness is determined the objective function representing the fitness on how good the solution is. The brighter firefly, the better solution. The optimization goal is to find the optimal solution by treating potential solution as firefly searching for the brightest location. For this algorithm, we require three rules, that is unisex attraction where all fireflies are unisex. Any one firefly can be attracted to other firefly regardless of sex. A firefly brightness is directly determined by the objective function, that is brightness is equal to f of x. A less bright firefly will move toward the brighter one. If the firefly finds no firefly brighter than itself, then it moves randomly. The attractiveness is proportional to the brightness. It is a mechanism of movement where the attractiveness decreases with distance between the two fireflies. The assumptions of algorithm. In this firefly algorithm, it has few assumptions where the fireflies are attracted to each other. Attractiveness is proportional to the brightness. A less bright firefly will be attracted to the brighter one. Attractiveness decreases as the distance between two fireflies increases. If the brightness for the both fireflies is the same, then it moves randomly to explore the search space. All new solutions are generated by the mix of random walk and attraction between the fireflies. Now, coming to the real world application, Firefly algorithm is used in various fields such as biomedical and healthcare. In this, the tumor classification and detection is used, also in health monitoring system and even for the medical image processing. In engineering and design field, antenna design optimizations, scheduling problem, and structural optimization is dependent on this Firefly optimization. And for the machine learning, they are used in feature selection algorithm, image compression techniques, and pattern recognition system. So this is our core idea behind the Firefly algorithm, how it moves things and learns from the brightness. Now that we have looked into biological inspiration, we and the fundamental rules, this is our main topic for Firefly algorithm. Now Dhruva will take over the mathematical model and working steps of the algorithm. Thank you.
I'll be taking over for the algorithmic workflow of Firefly algorithm. So let's look at our flowchart. We have a start, so the algorithm initializes. We generate initial population by creating a random population of fireflies. We evaluate the fitness. The fitness of all fireflies is evaluated using an objective function. So this sets their initial light intensity. We update the intensity of the firefly. We rank and we update the positions. Fireflies are ranked and accordingly, and the positions are updated. So less bright fireflies move towards brighter ones. So the algorithm checks if it's reached its maximum iteration known as Tmax, and if it's not reached, it will loop back to evaluating the fitness. If yes, the loop stops and we get our optimal results. Okay, we look at the pseudocode. So the pseudocode shows the underlying computational logic of it. After defining our objective function f of x and generating an initial population xi, there's a nested for loop that compares every firefly I with every other firefly j. And the critical condition is that if I j is greater than I, that meaning if the firefly j is brighter than firefly I, I moves towards J. So the movement is again controlled by attractiveness, which decays with distance r via an exponential term that we have here. And after movement, new solutions are evaluated. The light intensity is updated. Finally, the fireflies are ranked, and we find the best solution before the next generation. Okay, so to summarize the execution flow of this algorithm, first we initialize a parameters like there's n, then the intensity of brightness, then the distance. Then we generate a population of n fireflies. We calculate the fitness value. We check if our condition, that is t is equal to the max number of iterations, as the iteration t is equal to the max t. We update the position, the light intensity for each firefly, and based on the attract and the positions are updated based on attraction. Then we give out the best solution. So the key parameter is n, that is the population size. That is, it gives us the number of fireflies in a swarm. Then we have light absorption. It controls the rate at which light intensity and the attractiveness decays with distance. We have beta naught, or initial attractiveness. That is the base attractiveness at zero distance. Alpha, that is the random walk. It calculates the magnitude of the random movement. Then we have Tmax, that is our maximum iterations and the maximum iterations. So our Firefly cycle works in this way. So we start again with our start or the initial solution. Then we move on to the movement, that is less bright fireflies move towards the brighter ones. They are driven by attractiveness beta, uh, and they're moderated by distance r. Then we have exploration or exploitation. That is, the process naturally balances attraction, that is exploration, and random walks, that is exploitation. Then we select the best fitness. Then we stop our cycle eventually after Tmax is reached. I'll hand it over to Ankit for the continuation.
Thank you, Dhruva. Let's have a walkthrough over a numerical example to see Firefly algorithm in action. So basically, we are using a minimization problem. So as the first step was, we initialize parameters. We initialize the population size to be 20, gamma to be 1, beta to be 2, alpha to be zero point 0.2, and the population size, yeah, and the upper bound to be 100 and the lower bound as minus 100. We calculate the initial position as lower bound equal to upper bound plus upper bound minus lower bound into random number between 1 and the dimension d, which is 10. So the next step two, as we told, is calculate fitness. We calculate the fitness of each firefly using the minimization function summations I goes from 1 to n xi minus 1 whole square, and we calculate the light intensity for the first six but fireflies, which is as follows in the table shown over here. Notice that the Firefly 6 with a fitness value 1.1329 was is the initial brightest among the group, while the Firefly 3 with the least brightness of 16.84 is the least bright one. So the next step is to check and prepare for update. Now we start the iterative process as discussed in the algorithms and flowchart by Dhruva. We use nested for loops to compare fireflies. For any pair of fireflies I and j, the conditional check is if the firefly j is greater than the firefly I, the brightness. So if it is true, then we update the position and move the firefly I towards firefly j and end the if. So we finish that, and the next step is to calculate the position. So the distance is given by r of ij, which is square root of summation xi minus xj whole square. And in mathematical lab context, we can it is shown as the following code below. And we compute the position of each uh, distance between two fireflies at position I and j, and form it in table over here. And we also calculate attractiveness, which is beta. We use attractiveness function beta, which ensures attractiveness decreases exponentially with distance. So the formula for beta equals to beta naught times e to the power minus gamma times r square, where r is the uh, distance between between two fireflies, and gamma is, as discussed by Dhruva, the light absorption rate. So the next step is the actual moment calculation. So now we calculate the moment uh, determined by the Firefly algorithm, which is as follows: x of I of t plus 1 is equal to x of I of t plus beta times the attractiveness function minus the previous history plus some bias, which is alpha times uh, epsilon I. So using this function, we can see the new light intensity for the first Firefly is turned out to be 2429, and the reduced alpha in this case was alpha equals alpha plus 0.97. So the new alpha is 0.97. This formula includes the current position, the attraction pull towards the brighter firefly, and the random walk component, which is given by alpha times epsilon I. And the next slide, we see that uh, the position and light intensity update for each firefly, and like we discussed in step 4, we iterate through it and uh, check for the condition if uh, Firefly J is greater than Firefly I, the brightness attractiveness function. So applying that, we can see that 16.8429 is subsequently greater than 3.24, in the sense the condition is true. Therefore, we move the Firefly I equal to 2 towards Firefly J equal to 3. And then uh, we do this to find a better solution, which is pushing the Firefly towards the brightest one. And finally, we can observe the case of random movement in the next slide. Uh, as you can see, this is the formula for updating position for each Firefly. And in the next slide, we can see that the new light intensity for the second Firefly was found out to be 1.5397. And similarly, we can find the light intensity for the subsequent rest for fireflies and compute them as shown in the next slide. So as you can see, the new values are found out, shown as no new fitness values are shown as in the table over there. And over here, we can see that the Firefly 3, which is I equal to 16.3, and the Firefly 4, which is I4 equals 6.1690. The condition I4 greater than I3 is false, as Firefly 3 is already less brighter than Firefly 4. In this scenario, we can see that the Firefly 3 having no longer brighter neighbor to move towards, move randomly. So the Firefly I equal to 3 moves randomly uh, and becomes into after finding its new light intensity, it becomes 3.1663, demonstrating how random movement helps explore new positions when when the condition is not met. So in the next slide, we can see after this process is iterated through, we find the new updated fitness value and light intensity for each firefly. And the new most attractive firefly is turned out to be the fifth firefly, and the least attractive firefly has turned out to be the second firefly. So this iterative process of calculating brightness, distance, and moment continues until Tmax is reached. So that sums up step-by-step numerical workflow for Firefly algorithm. And you can see that Firefly algorithm is an elegant nature-inspired method that uses simple principle of light-based attraction to efficiently solve complex optimization problems by constantly balancing exploration and exploitation. Thank you for your attention.